morning at 12. I'm going to read to you from a notebook. This one says, stick by a friend in crisis. Some friends make us feel really great, and being with them is like taking a walk on a first day of spring. But how do you feel about taking a walk when it's cold, or when it's stormy, or on a winter day? And right now we're looking at a lot of things that's putting our whole way of doing things into a tailspin. And I just want you to think about all of the friends in our class, everybody that's not here today, and think about a way to reach them at this time. Because that's what I'm looking at, trying to reach you and make sure I can connect with you. And we're going to be looking at our Google Classroom. We're going to use email, YouTube, Zoom, and just all sorts of things, just to stay connected. So see if you can make sure we keep that connection for us as a group. I'll give you all that information and email you my URLs and all these fancy addresses so that we can stay connected. Okay, so today we are looking at a continuation of the topic that we did on Monday. On Monday we talked about the area that is just below the curve. So I'm going to show you just looking at this space. This is what we had on Monday. So we had a space like this, a little function, and we said, what if I wanted to find that area? Right? So we said if I looked at my area, I identified this as my x-axis, right? And I said this is just going to be my function, and I ended up calling the x-axis g of x. And our g of x, we said on Monday, was equal to 0. So we had a nice time just looking at our space. This is my A, this was my B, and I said, okay, I've got an A, I've got a B, and because g of x is 0, all I ended up was saying I've got f of x minus my g of x, which happens to be a 0, dx. So eventually that's all we did. Okay, so now today we're going to look at a slightly different curve, looking at the area between two functions, two functions, and we actually want to say, if I now have a space, what if I have a space? I still have my x-axis, I still have that space, but now I'm going to draw my function, but I want to say, what if I have that? And I end up with this area. Okay? So now I've got a space that looks like it's below my x-axis, and it's a space that I want to occupy in this area. Okay, so if we call this our function, so we end up with our f of x in that space, what do you think we can do? And we acknowledge, okay, there's our x-axis, again, is a 0. Now we've got a function, I'm going to just keep going on this side. I call that A, I call that one B. I've still got my little space, still got my A, still have my B. If I look at my function, the top minus the bottom, so I've got my upper space minus my lower space. So here we had the upper minus the lower, so we had f of x minus g of x, but this time, what's the upper one? It's again my x-axis, isn't it? So now I've got the upper space being, and if I call him g of x again, just because that's so much fun. So I call him g of x and I say that's my upper space, got my g of x, and I'm going to subtract him, so minus my f of x. So I've got that situation again, but I've got something different now because that g of x is, what is he? He's the same thing like he has been the whole time. He's equal to 0. Yeah, he's equal to 0 again. So if he's now a 0 minus f of x, So he's essentially going to just not become anything. And I end up with a b, and I've got here a minus f of x. Oops, got him. Tx. And in order just to make my function, to integrate my function, I'm going to take that negative, put him outside of my integral side, and what do I end up with? Of my f of x dx. So in other words, for us, calculating the area between two functions, for us, the function of the straight line and the function of this curve is below the x-axis, meaning that that space, this area, and I'm just going to make a reminder, the purple one, that's that one, this area is therefore a negative number. Okay? You stop there.